All right, guys. Yeah, I'm used to getting a feedback from the speaker here, usually, but it's a pretty cool setup. Really nicely organized. I'm just waiting for my slides to load. Hopefully, any second now, or maybe we just roll like this. I guess we roll like this. Hey guys, I'm Vaibhav. I also go by VC. I'm one of the founders at Socket. Socket's been live for the last couple of years, and today I'm quite excited to be here because this is one of the first hackathons that we are sponsoring, and we just released an alpha testnet for Socket Protocol last night, pretty much. So this is fresh out of the oven, and I'm going to give you guys a walkthrough of what Socket is, right? So hope you guys can follow me along. If not, you can find me at one of these booths after the talk is done. So really, Socket is the first chain abstraction protocol. And what does chain abstraction mean, right? So chain abstraction is pretty known for the end user. For example, you can think about chain abstracted balances as something that is making it super easy for you to perform one-click action with assets spread across all networks, right? So you might have 100 USDC on Arbitrum, you might have 100 USDC on Optimism, but now boom, you can spend 200 USDC on base for any action that you want pretty much instantly. So that's like chain abstracted balances, sort of removing the balance fragmentation that we have across all chains. I have a nice Uniswap screenshot that sort of like showcases what it might look like in the end game, right? No more bridging, basically. Then we have something called chain abstracted swaps. So from a user perspective, you are just able to do like swaps across networks. You no longer bridge. You just go from this thing called Luna on base to WBTC on Arbitrum. You just do swaps. You don't really care about bridging. So that's chain abstracted swaps. Then we have chain abstracted accounts, which is the same concept but applied to like smart contract wallets. So all of this is like very cool and intuitive from a user perspective. But really why I am here is to talk about chain abstraction from a developer lens, right? Because I used to write a lot of code before, not anymore. The team at Socket is super talented, so my PRs don't get merged anymore, sadly. But really, I do understand the developer pain here. Why manage your contracts across like 10 different networks? Super hard to manage, super hard to configure. Your users need to bridge. It's just an awkward building experience. And if you have to compose, or let's say if you decide to build on a chain that does not have Uniswap, or if you decide to build on a chain that does not have pump fun, all of those users can't use your protocol directly. So you can't have your smart contract on this chain that you are on talk to another smart contract on that chain without passing some like awkward messages between two different smart contracts. So I think that's what I'm here to talk about, right? So I think chain abstraction is, other than just being a new paradigm for users and user experience, it's also a new computing paradigm for developers, right? So chains are like, all of us think about chains like some like weird, sort of like L1 thingy, L2 thing, super complicated, but really just like think about chains as servers and databases, right? And chain abstraction enables you to like forget about your application and that it's deployed on a particular chain. Your application now sits globally across all chains at all times, and any user or any asset on that chain can directly talk to your application pretty much directly, right? So far, all of us are used to sort of like deploying our contract on a chain and executing our contracts on that chain. But what if you could build somewhere else and just execute your smart contracts on chain? So today you build and you deploy and you execute on the same layer. What I'm asking you to do is sort of like build on this chain abstracted platform, so such that your contracts can get executed on any chain at any point in time, right? So I think Vitalik also talked about this general play in one of the posts called Glue and Co-processors, where he was talking about how modern applications are built out, where there's usually this component of glue, which sort of like holds multiple processes together, and then you have multiple co-processors that are just doing the execution of things, really, right? So I think we want to like bring that to Web3, right? This is how your normal Web2 applications also work. There is a API gateway, and then you have microservices, and you sort of like deploy and scale horizontally, right? So what is Socket Protocol? Socket Protocol is a developer-facing platform. right? It is not a chain. It is not a roll up. It's a platform that you can use to like build on chain, right? We enable developers to write something that we are calling an application gateway, which helps users and developers manage their on-chain contracts better or like interact with their on-chain contracts better, right? Socket makes sure that developers at all point in time have like full control over the core infrastructure and are able to like modularize and like sort of like tweak with essential properties of this core infra that is Socket that is being used for their on-chain applications, really, right? Um, so my argument is that gateways, these application gateways enable chain abstraction because now application developers can write logic that runs off-chain and combine that with logic that runs on-chain, right? This off-chain logic can be written in simple Solidity. And these off-chain programs are run by these entities that are called watchers. If you can see them on the image there are like 4 different watchers of like different colors. So you deploy your contracts not just on-chain, where I've written like your on-chain smart contract, that's your on-chain smart contract, but now you can also write your gateway and have your gateway talk to your on-chain contract and provide the seamless chain abstraction to the end developer, right? So I'll just like quickly walk through to with some Solidity examples to show you what the difference is really. There is no need to like look too much into the code. It's just there for the reference. But if you quickly look at the image that I have here, there is a contract called first node, there is a contract called second node, and there is a contract called ordered noter, right? And there is only one function in ordered noter, which is write notes. And all it does, it calls like the 2 node contracts, and that's pretty much it. Like really simple contract. We have first node, second node, and an ordered noter that calls both of these contracts. That's pretty much it. All of this is happening in a single chain right now. What you want to do next is sort of take these first node and second node contracts and put them on different chains and see how you would compose them in like today's world where chain abstraction does not exist. How you would do that today is by passing messages between these two contracts, and that is pretty complicated. So I have just added the code here so you can like see how complicated it is. Oh, I know it's pretty blurry, so you can't like read much, but this is how much code you need to probably write to have these 2 smart contracts compose and talk to each other, right? Although with chain abstracted composability, now the first node contract can be on chain A, second node contract can be on chain B, but just like the first example, where the write node function was just able to call set node, in chain abstracted composability, you can do the same thing. The only difference is that async modifier, which you guys probably can't read at the moment, that's the only difference, right? So you just add an async modifier, and now you can do asynchronous calls in pure Solidity, right? And this thing is running in this watcher node that I was like talking about before, right? So I think like this is what we are here to sort of like present today, and something that you guys can build upon. Would love if you guys can play with this stuff and build some cool things. Now, other than just like composability, since this application gateway sits above all chains, you can run some special logic here. I call this special logic pre-execution logic. So think about this stuff as logic that you want to run before your on-chain contracts are executed. So imagine that you have like a lending protocol on-chain, and you don't want this lending protocol to be hacked, right? So what you do today is you sort of like go and you find someone that like causes a pause function when something bad happens. But what if you could write a security invariant inside your application gateway that automatically detects if this particular action is going to like cause or like break a particular invariant? Or you could run an auction inside this pre-execution logic that ensures your intents are being fulfilled in the most optimal fashion. So so I want like people to use this stuff to do smart contract composability across networks, as well as run some pre-execution checks. You can like scan it to get linked to the docs. And today we release an alpha devnet. We are running a single off-chain VM at the moment, a single watcher operator. You can scan the QR code, you will go to the docs where you can find like how to interact with that VM and how to build on top. We have some very nice bounties out there, very, very, really like edge case bounties, and that is what I want you guys to do, sort of like explore the edges of this stuff. So I want someone to build a horizontally scaled application. So instead of you deploying a contract on one chain, deploy a contract on n chains. And then whenever there's like a lot of traffic, instead of sending it to one chain, you like spread it across n number of instances so that your users are paying a minimal gas costs, right? So that thing can be super cool. Then there is just like a general bounty of like pre-execution and composability, whoever cooks up the best thing with it. And then at the end, I would love to see someone cook up with AI agents and socket protocol. There is one I particularly like called ELISA framework, but feel free to use something else if you like it. We want to do, so we have a starter kit that you can like download, clone, and start using. We have Francisco here from the socket team who will give us like a quick rundown of the starter kit. One sec.